All right, so this section, actually, this lecture is going to be Chapter 1, Section 1, and it's going to be coordinate systems and graphs. Okay, so it's going to seem kind of basic, maybe. This is where the beginning of the book starts, so usually it's a little bit more basic. So the first thing is, example 1 says, graph the points negative 3/5, 1/2, and 15/8 on a coordinate line. So a coordinate line is not your graph. It's not your normal x and y axes. It's just also called a number line. So we're going to draw a number line to start off. So I'm going to attempt to draw a straight line with this, and this should work okay. And I'm just going to put the points, let's say -2, -1, 0, 1, and 2. So first, we're going to graph the point negative 3/5. So negative 3/5, again, is negative. It's on the left side. This right here, I should label these maybe. This is what we call the origin, our neutral number here. And then everything to the left here, these are all of our negative numbers. And then everything to the right, these are all of our positive numbers. The origin kind of separates the positives and the negatives. So we have negative 3/5, and negative 3/5 is going to be on the left side of the origin, but it's not quite -1. It's smaller than -1. Bigger than -1, but smaller than 0. So it's in between -1 and 0. So it's somewhere, let's say, right in here. We're going to label it as negative 3/5. Next, we have positive 1/2. So that is right in between 0 and 1. So we're going to put it as close as I can. So that's a little off, so I'll make my dot maybe a little bit bigger. Be kind of more in the middle, so it's 1/2. And then I have 15/8, and 15/8 is really 1 and 7/8, so it's really close to 2. So we're going to put it closer to 2 here. We're going to say this is 15/8. How I know it's 1 and 7/8 because 8 goes into 15 once, and then what's left is 7, so it's 1 and 7/8. All right, so next is probably what you were thinking about when I said graph, and it's coordinate plane. So you have the x-axis and the y-axis. Your x-axis is horizontal, so it goes left to right, and your y-axis is up and down, so it's your vertical axis. And then again, there's your origin right in the middle. Separates the positive and the negatives. So example 2 is we're just going to plot some points. All right, so I'm going to draw my x and y axes here. One, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I got a little crazy with my tick marks there, but at least they're big enough you can see them. So first off is 2, 1. Right, so 2, this means this is my x value and my y value. So I'm going to go over on my x, 1, 2, and I'm going to go up 1 on my y. Positive is up, so it's right there. So 2, 1 is the point right here. 2, 1. My x value here is -1, and my y value is 3, so I come x is -1, so to the left of my origin. And it's positive 3, so I'm going to go up 3, 1, 2, 3, so it's right there. So this now is the point -1, 3. Next, I have the point -2, -1. So -2, and then now I go down 1 because it's negative, so I'm right here. So -2, -1. And last point here is 0, -3. Well, 0, there's no x value here. So I don't have to move left or right. I just stay at the origin, and then I move down 3. 1, 2, 3. And we actually call this a y-intercept because it intersects the y-axis. All right, so that's how you would plot some points. Next, if I just said sketch the graph of the equation y equals 2x, and you say, hey, I don't know how to graph. Well, what could you do? All an equation is and the x and y. The x and y's represent points on that line. So if you don't remember how to graph it, just create some points. What do I mean? Well, my x value and my y value. Let's say I make my x values, let's pick some. Let's say it's -2, -1, 0, 1, and 2. Let's say we pick 5 points. So I'm forcing my x values to be -2, -1, 0, 1, and 2. What I'm going to do is I'm just going to substitute in these values into that equation. So I say 2 times -2, that equals negative. Oh, sorry, and then not equals. Yeah, equals -4. So this point that I'm going to be graphing is the point -2, -4. Next, now I have 2 times -1. That equals to -2. So the point that I'm graphing here is -1, -2. Now I have 0. What's 2 times 0? 0. Oh, look, it's going to be a point at the origin. And I keep going with this. And then now, just like we did in our last example, we just plot these points. So why don't you go ahead and pause this and then go ahead and plot them and see if you got it right. So how'd you do? It looks something like this. I know my line kind of got a little crooked, but when you have a little sloppy makeshift graph, it doesn't always turn out to be the most accurate. But you get the idea. All right, let's move on. So we have something called, well, we have all these are called linear equations. And we have something called standard form and slope-intercept form. Now the book calls a lot of these just standard form. All right, talks about linear equations, standard form. So I'm going to give you a little bit different title, and we're going to work like this. A standard form is you have an equation that says ax plus by equal to c. And a, b, and c are constants. They're just numbers, right? They could be 0, could be negative, could be positive. This is really good for when you want to try to find the x and y intercepts. All right, now, slope-intercept form. Slope-intercept form looks like y equals mx plus b. And your m is your slope. And then your b is your y-intercept. And really it looks like this, 0, comma, b. So if that was a +2, the point you would be graphing would be 0, +2. If it was a -5, if it was -5 back here, then you would be graphing the point 0, -5. All right, so example 4 says find the standard form of 8x minus 4y equal to 4. And what I really want you to know is that you're not really finding what we said at standard form. That's why I put quotations. Okay, what it means is it wants you to put it in slope-intercept form or a way that you can graph it. And right now we're only graphing y-intercept. Sorry, slope-intercept. So you want to, in this, is you want to take this 8x minus 4y equal to 4 and put it in slope-intercept. And if you recall, our slope-intercept form is y equals. So we want this to be y equals whatever is left on the right side. So what we're going to do is we're going to move things over and solve for y. So in order to do that, I'm going to subtract 8x from both sides. And I'm left with -4y equal to -8x plus 4. And then I'm going to get y by itself by dividing everything by -4. And now I have y equal to, which is 8 over 4, which is 2x. And that should be 4 over -4 is -1. So this is the answer it's looking for. Now over here, it says 2x equal to 6. Well, that means we can't graph that, right? We have to, it has to be y equals or x equals. And because there's only one variable, we're going to make it x equals. I'll tell you how to graph that shortly, coming up soon. So you're going to solve for x by dividing both sides by 2, and you get x equal to 3. And I'm going to show you how to do this. What this is this is called a vertical line. So a vertical line is, it'll say x equals some number. All right, so if I had a graph, and I said I needed to graph x equal to, say, I don't know, 3. Well, I would go over 1, 2, 3 on the x-axis. It looks something like this. That's x equals 3. If I had to graph the line, let me draw my coordinate plane over here. Let's say I had to graph the line x equals -4. When I go over, when I go 1, -2, -3, -4. I just missed that mark, didn't I? Let's fix that and say it's like this. And that would be x is -4. So a vertical line is x equals some number. All right. Now intercepts. I already talked about them. The next intercept is a point that lies that has a y-coordinate of 0 and it's on the x-axis. A y-intercept is opposite, has an x-coordinate of 0 and lies on the y-axis. So there's a couple different ways you could do. It says graphing y equals mx plus b. The first thing you can do is how to graph this is plot the y-intercept, which is 0b, and then use the slope to plot a second point. If the slope makes the second point fly off the graph, so let's say the slope is like 10 over 20 or 10 over 17, and you can't use 10 over 17, what do? Then you can graph the x-intercept, and I'll show you how to do that. Oh, and sorry, and then you would draw a line to the 2 points. So let's graph y equals 2x plus 1. So first, let me draw my coordinate plane here. Okay. So first thing, I need to graph the y-intercept. This tells me my y-intercept right there. It's the point 0, positive 1. So it's right here. There's my y-intercept. Now, the slope you're going to learn about in the next section. This section, we're going to pretend like our slope makes it fly off the graph, and we want to find the other intercept. So we're going to say the x-intercept. Well, remember what we said in our definition. The x-intercept is a point on the graph that has a y-coordinate of 0. I can force this y-coordinate to be 0 by saying y is 0, and I have 2x plus 1. And now I can find what x is. So subtract 1. Divide by 2, and x is -1/2. So the point that I'm going to graph here now is the point -1/2, 0, which is right there. And then now I can take and plot my line. Okay.